yeah, brain surgery is not by any means perfect. It's pretty archaic and it's pretty scary.
Our team name is Triangle Medical Innovations. We chose that because we have half our team from UNC, half of us from NC State, and we are working with neurosurgeons at Duke Hospital.
This all started over the summer when I got an email about participating in the joint team at Duke.
And then I got an email from Brene, and she was just like, hey, we're doing this joint senior design team. Do you want to be on the team? And I was like, yeah, why not?
So we went into Duke Neurosurgery and we shadowed. We shadowed for over 60 hours as a team. We went in these surgical rooms and watched open brain procedures, open spine procedures, and identified over 150 needs.
Dr. Fetchy was our primary mentor, and we just kind of sat down and we had this list of problems that we all went over, and the first thing that came about was this foot pedal, and this bipolar thing sucks.
They have several foot pedals that control different things. One of these controls a bipolar electrocautery device.
And in trying to use the foot pedal during brain surgery, they can misplace the pedal and they either need someone else to activate the tool for them, or they are searching around for the foot pedal, and this is a problem because they need to be focused and have stable hands in the surgical field in order to safely perform brain surgery.
So then we went into some operations, and we were watching for it, and we actually counted how many times a surgeon who had tools in the patient's brain had to look around for tools or ask someone else to actuate the tools for them. And it was something ridiculous where, like in an hour of operation, the surgeon was distracted maybe 30 different times or something like that, like looking away or looking down, trying to find the pedal.
So our solution to the problem has been a voice activation system that does not require any kind of motion from the surgeon, and it gives them complete autonomous control of the bipolar.
I mean, you have it with your phone and you have it with your car. So why not neurosurgery? Why not in the operating room? Bipolar. Off.
Neurosurgery is an extremely dangerous set of procedures just because of how delicate the brain is itself. So any device that could potentially reduce the movement in and around the brain just really makes it a lot safer for the patient.
If you went up to any neurosurgeon, they would say, I want this because this is a problem that maybe I didn't even realize I was having. But once you present me with the solution, I realize this is so much better.
Our solution will make things better because it reduces the chance of them searching around for the foot pedal, and so they're not going to move as much in the brain. Right now, 1 in 5 neurosurgeons face malpractice law claims every single year. And so a lot of that has to do with different things going on in the neurosurgical room that they can't control, and one of those is a foot pedal moving around.
Well, the way I think about it is that if you ever have to go in for neurosurgery, or if someone you love ever has to go in for neurosurgery, I would want it to be the safest possible, obviously. With the voice activation, I think that I would feel way better about it than with the foot pedal activation.
When I look at some of the other senior design groups, I mean, don't get me wrong, some of them are great, but like, I am so glad that I got the opportunity to be in this group. It's been great.
We definitely would like to see this project all the way through to have a product that can be used in the operating room. Rather than just developing a prototype, I think that the end goal is to have something that actually makes the difference that we want it to make, and get it on the market, get it out there, and have it make the impact.